1080p. Yo.
It says we're live, so I'm going to assume that we are. So Lee in the chat is asking if we're starting soon. I think we just started, son.
It's 4 o'clock exactly right now. What the heck?
How you guys doing?
4
Pretty
o'clock
good,
here.
man. How you doing, Nate? Chuck?
I went through that video today. Holy cow. I had 48. I have 48 clips and I used 30 something of them for that.
Isn't that fun?
This is for the face array.
And I still have one to do.
I haven't had a chance to watch it yet, but I put in a honest half day of work today.
You had to drive and everything.
I did, and it was a pain in the butt. But here we are. We're going to talk about questions, the biggest questions that we often get asked by hams, and we'll just go through them and one by one and tackle them. And if you have any questions, you can post them in the chat, and we'll do our best.
Mm-hmm.
Dave, how you doing, man? And James, how you doing?
James.
Yeah. So anyhow, oh, look at this. We got the other James in here. What's happening, brother?
Yeah.
That's my Miller Lite buddy.
That's right.
And then Chris Radio and Life. How you doing?
Hey, Chris.
That's right. He gave you Miller Lights at the.
He sure did. He kept me hydrated. And then Chavez, how you doing?
Chavez.
Randall Rash, how you doing, bud? All right. Well, before we go too far down the rabbit hole, let's hear a quick word. Innovation moves fast. So should your PCB manufacturing. At PCBWay.com, you get high-quality boards, expert assembly, and fast, reliable worldwide shipping, all at prices that make sense. Whether you're a student, hobbyist, or engineer, PCBWay.com helps you move from concept to creation without missing a beat. Speed, value, and precision, only at PCBWay.com. Man, I sound good in those promos, don't I?
You do, man.
Yeah.
It's starting to get like broadcast from that voice.
Yeah.
It's coming out. I can hear it. You got that broadcast engineer coming out of you.
Yeah, I guess. But now, thanks to PCBWay.com for sponsoring this show. It's much appreciated.
I didn't know we were doing sponsored show tonight, man.
Yeah. Somebody's got to pay the bills around here.
So that means Chuck has to file his taxes different for tonight.
Let's don't even go there. William Bello. I talked to William, Mr. Bill, last night.
You talked to him on the air after the last show, right?
He did, and I was there right there with Chuck when he did it, and Chuck just put the hammer on him.
What, 500 watts?
I gave him a full 100 watts, man. 20 over, he said.
I don't know if they have CAD software. I know that you can upload your Gerber files, and I believe you can link certain like KCAD, I think, or KeyCAD. I think you can link to their website and just upload directly from that design software.
Nice.
Thanks, 45.
I missed it. What did he say? Hold on, I'm still bringing.
He said my impression of Walter Cronkite.
He didn't say anything.
Your Cronkite's stepping up. Is that what he's saying?
That's what he's saying.
Nice.
All right. Well, feel free to jump in, guys, as we go through the questions. And let me just go ahead and add that one to the stage. It's not what I wanted to do. I wanted to do this, and I wanted to. One of these days, I'll learn how to work the software correctly. But here we go. Question number 1. How do I know what frequency my antenna is tuned for? You guys ever run into that problem?
I know where mine's at, usually.
Well, yes, because
there's different answers, actually.
I've got 2 antennas that like to drift around.
Well, I've got
I do too.
I got sent to Yagi for review, and it says that it's good for 2 meters, 70 centimeters, and GMRS. And I've got a hard time believing it's good for all of that.
Yeah, I got the same antenna hanging on the wall over there, actually.
And so I think you said it was 70, but
it is.
What I'm going to
do, it's the one I got.
I'm going to use an analyzer. And what I'll do is I'll just do a sweep and look where the dip is. And then wherever it's closest, I guess, is where I'll begin the tuning process. Hey, Vince, how you doing, bud?
Vince.
Jeff's saying if you ask nicely, it'll probably tell you. But I'll just use an antenna analyzer. Now, I like to use the Nano VNA, but these two knuckleheads, they like to use their rig expert.
Come on now, you know I got a Nano on deck.
Every time you send me a sweet picture, it's with a rig expert.
Because I want you to be able to see the picture. That's the problem.
And I'm usually don't have time to mess around.
I'm not doing like
what's easy
internal
and fast.
USB dump like screen caps or anything. I'm out, with the gnats and the mosquitoes, and I'm sitting there swatting my head trying to snap you a picture of something ridiculous. I ain't gonna get away with that on a Nano.
Nano VNA all the way.
That rig expert's got that contrast.
And Nano all the way, and then Billy Bellow saying he has a Smith charts and impedance listed on his QRZ. So I guess if you want to know what your antenna's tuned for, just go to your QRZ, right? He loves
He's got a lot of stuff on his QRZ, to tell you the truth.
Yeah, so it's the frequency with the lowest SWR indicates resonance, and that's kind of true, kind of not. Resonance is really where there's an absence of reactance, so there's no inductive or capacitive reactance. You can have antennas like a dipole, for example, mounted at a half wavelength above ground is about 73, 74 ohms at its resonance.
It'll never be a 1-to-1 on the swerve.
Right, your swerves are not 1-to-1, so it wouldn't be the lowest SWR.
1.5 at the best, maybe 1.4 if you have a little bit of an extended, little bit of a.
I've seen them be the lowest SWR before, though. But
no, they go lower. They go lower, but what you're doing is it's called loading, right? And then so before your choking point, you're actually extending, you're off centering the antenna, and it's creating more resistance from a longer counterpoise.
Yeah, and then if you need to tune, you can trim or extend your elements based off your SWR reading. So it's really nice if you have an antenna analyzer that shows you the frequency dip or the SWR dip.
Oh man, there's William right there after you with the dip meter.
Yeah, you can move it that way. The other thing you can do is you can adjust the height above ground for your HF antennas, and that will impact your your swears. And the other thing you can do is sometimes change the angle. Like if you have a sloping antenna, you can change the angle, and that would adjust your SWR. Sometimes moving, if you have like a sloper end fed half wave, the height above ground for your transformer might make a difference. Or if you have an inverted V, adjusting the apex can adjust your SWR as well. This is a picture from my Nano VNA, and you can see at marker number 2 is where I was closest to resonance in this particular screenshot, and I was at 1 to 1.086. This was a vertical antenna that I was tuning. The green line indicates its position on the Smith chart, and you can see that I am slightly capacitive. But that was pretty good. I was pretty happy with that.
Which antenna is this?
It was a vertical, coil-loaded vertical that I was playing with out back.
Okay, this is phenomenal for a coil-loaded anything.
Yeah, because they said on the packaging that in the instructions that it could only be tuned to 1.5.
That is phenomenal. Which 40 meters on a wow.
Yeah, I don't remember which one it was, to be honest with you.
How long were your radials?
I had 4 17-footers. They might have been 15-footers, but I always overdo it a little bit with the radio playing.
That's amazing.
I was happy with it, and it performed pretty well, if I remember correctly.
Maybe it's just bad readings with that machine you're using there.
maybe.
You might have to use a rig expert, right, Chuck?
Or get the accurate reading.
True. Get something.
But when I think this was the antenna that I was using when it was really, really bad band conditions. It was like when we were having all the solar flares, and and everything was door nail dead. But it tuned up nice, so I was happy about that.
You don't get that special beneficial factor of owning a Nano VNA by doing this calibration thing all the time, though.
Well, I just do my calibration and save it to one of the memory slots for the frequency spans that I use the most. So
I do too. I'm poking fun that we don't calibrate our rig experts.
Right. Yep, it's called VNA Saver, and I like that software. All right, let's see what we got coming up for number 2. People ask, can I build my own antenna?
Yes.
And we're 3 nerds that like to build antennas. That's probably what we do the most, right?
Yeah, we should have had Jim tonight, and then we had at least one person that doesn't like to build antennas.
I do really awful things, guys. Don't leave me alone with tools.
Yeah.
It's pretty bad.
But building your own antenna, it can seem intimidating at first. And, folks are like, well, I don't know what to do. I don't know what I need. What I would suggest is that if you're going to work on building your first antenna, I would talk about getting a kit, right? And put a kit together. It comes with everything you need. It'll come with instructions, and most companies will support you if you run into a little bit of a problem there. It's not a bad idea. It's you can save a ton of money building your antennas. Like I can build in, I don't know, an antenna for $50-$75. And that's probably on the excessive side. Or I could buy one for $150 to $200 for the same antenna.
Right.
Not getting all the parts, but over time, if you start building antennas, you start accumulating stuff fast and build up a pretty respectable parts bin to make it pretty easy. So antennas are DIY friendly. There's tons of plans, tons of YouTube videos. I think all of us have tons of them showing you how to build antennas and things to watch out for and different techniques you can use. You can build them from wire, coax, PVC for certain things. It's cost-effective, educational. Common projects that people like to build, dipoles are really good antennas. A lot of people don't like them because they're single-banded, but dipoles perform really well. Super duper easy to build. J-poles are really popular for UHF and VHF.
I did a successful J-pole build out of copper pipe. I think it was 1/2 inch, maybe.
Carlos built a 20-meter J-pole.
That's crazy.
It was actually the best antenna he ever used on one of his or HF antennas he ever used, I think.
And he jumped out of a plane with it. I think the guy's nuts.
Hold on, wait a minute. We can't compare everybody's ground mounted J-poles to some guy jumping out of a plane with some RF.
Yeah.
I wasn't comparing it to ours. I was comparing it to all the other stuff he used.
Oh, that he used.
Yeah, jumping out of the plane. I think he had the best results with the J-pole.
Okay.
That was like the antenna he did. He's using something else now.
I'll step out of that one.
That's good.
And NFEDs are super easy to build, and it's a really popular thing to do. And it's good for learning. It helps you learn about resonance because you have to tune it in. It helps you learn building techniques, make you better solderer. Building transformers is part of that, or chokes and stuff like that. And it makes it easy so you can troubleshoot if anything goes wrong. And when you do buy an antenna, thing that drives me bonkers is antennas that are not field serviceable, right? So if you build antennas, then you can do field service if you need to go out and fix something.
That's rule number 1, right? You got to be able to fix it.
Well, a lot of manufacturers want to build an antenna and then seal it up so you can't see what's inside of it. So they
fill them full of epoxy or glue.
Yeah. So you can't do anything.
And then after they glue them in epoxy them, then they hermetically seal them, which is like insult to injury.
Yeah. And sometimes they just break. I mean, I've seen really well built antennas kind of cheesy.
There you go.
Construction sometimes. The box for it or wherever it's built in is really good, but inside is where the problem is. It's not built very well inside sometimes.
Chavez is asking what toroid mix use for a common mode choke. The first thing I would tell you is that I like to use 31 because it's very broad banded. But somebody was saying here, James is saying it depends on frequency, and that's true. A lot of folks like to use mix 43 as well.
I like to use 243s.
Yeah, it just really depends on what you're doing and what frequencies. But a good rule of thumb is that 31 is super broad banded and works pretty well. I don't think it's the best on 160, but I think 80 through 10, you'll get reasonable performance. Also, how you wind it and the materials that you use to wind it it's choking.
If you're doing some of the higher bands like 6, make sure that your common mode choke is 4/6, because I accidentally hooked one up when I had 2 that were kind of the same. hooked one of them up, and for some reason I couldn't get my antenna tuned, and finally looked at the thing, and it didn't cover that. I changed it to the other choke, and everything was fine.
So I recently
luckily I didn't go too far.
High performance, a super high performance dual bifilar choke for a gentleman that was really interested in the 28 megahertz 10 meter area.
20, you can say 11. You can say
anyway, we're CB friendly. We're CB friendly here.
So anyway, so 28 megahertz, and he wanted the most choking, and the final product that I tuned for him with 261 mix was just almost, if not touching, negative 60 dBm, which is
this is the Donkey Stomper guy, right?
Yeah. So I made a choke that was able to eat up about 400 watts of mismatch.
That's awesome.
Yeah, that's a lot of mismatch that it was eating up, and it actually didn't change anything, but just a number, which put his brain in a happy place and put cash in my hands. So
there is going to what a Donkey Stomper is. It is an unfiltered amplifier that splatters everywhere, but they're awesome.
No, I mean the radio's clean, so the amplified signal's clean, but it's just a lot of gallons.
I'd like to see that thing on the meter, but
it's always in the corner.
They're pretty popular.
It's always in the corner. Anyway.
Yeah, James, that's what I mostly use is the 240 31s.
Yeah. So 31s, you're going to get kind of a lower, better grab. The 43s, you can kind of be right in the middle, right around 20 meters. And the 61s is all for the high boys.
So people say, well, what is impedance matching and why is it important?
Super important. That's the only thing that I do with ham radio is impedance matching.
It keeps you busy, right?
Well, I mean, you can't make a proper in-fed half wave without, figuring out where you're going to be on your impedance for the frequencies that you're interested in.
Yeah, and what you want is your radio to look like it's seeing 50 watts of characteristic impedance on the output. I'm sorry, 50 ohms. And if it sees anything more than that, what you get is SWR or reflect, as some people call it. And that is power that comes back towards your radio. And there's tons of debate as to what happens when it comes back. But what we do know is some of that is reflected back out towards your antenna. What happens is that you do get loss along your coaxial cable. You also get higher voltages on your coaxial cable, which can be a little bit problematic. Modern transceivers have a fold-back feature. So if you're putting out 100 watts and you're getting reflected power back, the radio will lower its output powers to not damage the finals that are on there. Now, some of that problems go away if you feed into a tuner, and your tuner's not exactly 50 ohms on the output there. The output of your tuner creates what's called a conjugate match, which is a mirror reflection of the impedance characteristics your antenna sees. And that definitely creates a bounce back and forth, where most of your power will still continue to be radiated, but you lose it in lossy pieces of your antenna system, like your coax or any junction boxes or transformers, or anything like that. And Jeff's asking, doesn't Florida that reflected power actually adds to your power output? There is a guy on YouTube that did a video where he was saying that his reflected power actually increased his power output. And,
well, because it was all being forced onto the antenna and creating a bad match. And then when the tuner was on, the tuner was eating up the match, and then there was left. I've experienced this. Right.
Well, a lot of times I said,
hey man, here's my tuner on. How do I sound? How's it off? And he's like, dude, you sound louder with the tuner off. And I'm like, yeah, but my radio's real mad right now.
Yeah, well, you're probably getting lost in the tuner. But this guy had a really low quality SWR meter, and what it was doing, it was additive of the power out. So he was insisting that because he had high SWR, he was getting 130 watts out of his 100-watt radio, which is, it doesn't work.
This wasn't the same guy that had his meter in the wrong side of the chain, right? He had it in between.
He may have, but okay. the guy's a kook. The guy's a kook, but proper matching lowers your SWR. It protects your equipment and makes sure that you're transmitting as efficiently as you can.
Oh,
And
I got an upgrade.
Oh, let's see what you got.
I got the big Toshiba.
What is that, off a display or something like that?
A display? No, I had this custom built, son.
Yeah, that's pretty nice.
From BBI.
Well, you need a couple of them.
Well,
BBI.
I mean, yeah. So anyway,
we match with a couple different ways in amateur radio. So we use tuners. I have balance on here. Balance don't exactly match. What they do is they choke impedance. I mean, they choke common mode current. Common mode current can present itself as ISWR. Transformers like a 49-to-1, 9-to-1, 4-to-1, or antenna design. And then sometimes folks will make like LC circuits and stuff like that. The schematic I have here is what's called a pi network. And you see these pi networks. Most of the antenna tuners that you crack open today have a T network. So I've got videos explaining the differences and pros and cons of the different types of networks, matching networks. But the pi network is really an inductor in series with two capacitors in parallel. And you would adjust the capacitor. You adjust all of them, but what it does is it forms two L circuits. One's an inverted L pointing to the right, and then the second one is an L circuit, LC circuit pointing to the left. And you adjust the settings of each one of those to do a match when you're using a manual antenna tuner. Let's go on to, I think this is number 4. Might be, yeah, it's number 4. Why is grounding important for my antenna system? And a lot of hams actually don't ground. I'm not entirely sure that that's the best, the best or safest solution.
I got no skin here. Go ahead.
Yeah. So the first thing I have on here is listed as lightning protection, but I do want to talk about what we do is on each one of your pieces of equipment, you have a grounding lug, and it's best to run some thick copper from your grounding lug to a bus bar, and that's called bonding. And what that does is ensures all your equipment is at the same potential. So that way, if you touch different pieces of equipment, you can get a little bit of a shock. You can damage your equipment. Two pieces of equipment that are at different voltages, that voltage tries to balance itself out through any conductive material, including you, if there's connectivity between the two of them. And that can also cause problems with inside your equipment as well. So you want to take that bus bar, and then you want to make sure that it's grounded in some form or fashion. A lot of folks say that they're grounding via their power supply through the third prong on their outlet that goes into the wall, and that would be run into the mains ground outside. But that's station grounding and equipment grounding, not so much grounding your antenna system. Grounding your antenna.
It's a fine balance in between saving things like electrically and following code and how much RF you want to put out. It's a super fine balance.
Yeah, you're probably, everybody grounding is probably not doing it according to code, even if you have an electrician come out, because grounding is one of those black magic things that everybody thinks is should be done differently. But grounding your antenna, the first thing it can do is do static bleed off. Jody's giving me grief on my schematic from the previous picture. Son, have your poutine and maple syrup. Just calm down. We're going to get through it. Anyhow, grounding your antenna will help bleed any static charge off of your antenna into the ground as opposed to coming in the shack. One of the things I always recommend to people, they'll say things like, hey, well, when we have a storm, I disconnect my antenna, so I'm safe. And that's true to a point. But if you go back and you hook that coaxial cable back up to your radio after your antenna set outside in a lightning storm, you can have static build up on that antenna, and you can definitely smoke your equipment. So one of the things I always recommend is I always short. It's probably not the safest way to do it. My coaxial cable out with a screwdriver holding the insulated handle.
That's where that putting it in the glass jar of water come from.
Right.
Yeah.
Right. But you can, that if you have static buildup on your antenna, and then you take that coaxial cable and hook it up to your equipment, then you could have a little bit of a problem there. I don't want to out him, so I'm not gonna say who it was.
Me.
But I knew a guy who hooked his rig expert up to his antenna.
That was not
me. and he left it hooked up. It would happen to anything. So I'm not picking a rig expert. So it would happen to any. But he left it hooked up for a couple days. And what happened was he had static buildup on the antenna, and it smoked the insides of his rig expert. I guess they're not designed to be hooked up that long. But I don't think any piece of equipment would be.
So but in the world of RF and lightning and antennas up in the air, like anything's possible. Like we've all damaged equipment. There's not a single ham that hasn't like accidentally like blown up a piece of equipment. So I mean, we all learn by trials and failures.
Yeah. So grounding diverts energy safely to Earth, and protecting equipment and structures. But the challenge is that if you get hit with a direct strike, all bets are off. So grounding really helps you with near strikes when there's a lot of current or voltage in the air. And if you get hit with a direct strike, I guess your antenna could evaporate, liquefy, or whatever, or come in the house and blow up a bunch of equipment. Grounding also helps with RFI. So when we talk about RFI and common mode current that travels on the shield of your coaxial cable is always looking for the least resistive path to ground. And if that happens to be a grounding rod hammered out next to your antenna with a nice big fat strap of copper mesh braid on there, that's going to be the lowest path, the lowest resistance path to ground. And take noise, extraneous noise off your antenna system and get rid of it for you. The other thing I had on here was signal stability, reducing noise, enhancing performance for especially vertical antennas. Vertical antennas pick up a lot more noise than we would like them to. What I've been told is that a lot of man-made noise is vertically polarized, and vertical antennas seem to be prone to that. So I put a vertical antenna up and a horizontal antenna and tested them, and the verticals are always noisier than the horizontal ones. You guys experience that?
I've noticed sometimes that the noise is different sometimes. Sometimes the vertical actually was better for me. But yes, verticals usually have a little more noise, especially when I set stuff up in the backyard with that we've got like a spa back there, and it seems to pick up a lot of noise from that sometimes.
I've got a half square that I'll actually switch in between antennas during certain QSOs because I've got a half square that's got ears like crazy. It makes my in-fed wires like look really bad. Really, really bad.
Paul says he invites the lightning, points a hammer to the sky.
So as a half square, you kind of have, partial vertical, partial horizontal, right?
Vertical, horizontal, vertical.
Yeah.
Right. Sort of.
So you're all over the place. Chuck, you did a video in your half square, didn't you?
Yeah, I did. Well, I think I built a 20, but I had a 40 up at the house here, and it was, I mean, for distance, it was a lot better than my doublet at times. I mean, 2 or 3 S units sometimes. I know I got in South America with it one time, and I couldn't even hear with my doublet. But then talking to San Diego, it's the opposite.
Everybody knows there's nothing better than a doublet.
I was talking to a guy, and he was telling me that he was having trouble with his lot size. He had a small yard, and his house, there's only like 6 feet of lawn on either side of the house. Real small backyard, and he wanted to put up a big antenna, and he was like, what can I do? And I was like, dude, do a half square. Like do like an 80-meter half square and then mount it over the house. And that's what he did. I don't recall how well it worked out for him though. But that was the solution.
The advantage to the half square is you don't need any ground radios. So that's a good thing.
Yeah. How do I offload static buildup on my attic antennas? So there's a super high value resistor, and it's in the like mega ohms, and it will not present itself at all while you're operating, but it will slowly bleed off any static. So basically, any resistor in the mega ohm department will help you bleed off static, and you can attach that anywhere on your antenna.
Or put a lightning arrestor on that thing, and then the side of the lightning arrestor has a grounding lug, and then just ground it to your house or your mains ground.
Yeah, that works too. I don't have any of those. My coax go through the wall and then underground.
Those big old resistors, though, those things can get expensive.
They're the mega ohm resistors. Yeah, I mean, $10-$20.
Oh, I was thinking they were the ones I was looking at on Palomar were like 200, I think.
Really?
Yeah, somebody was telling me to get one for a like a smaller loop antenna. You put a resistor. So you basically build a dipole, take the ends, fold them around, and put a big resistor in the end of it. And I was looking at it. I was like, yeah, I think Will's saying like a double bazooka. And I was like, man, it just looks it was expensive. And I was like, I'm not sure I want to spend that kind of money to be disappointed for one reason or another.
I've never met anybody that has built and had a properly tuned double bazooka. I just want to throw that out there.
Yeah, I've never used one.
It's fun to say, but I mean, it's kind of like the unicorn in the wild.
That's Croc's favorite antenna is the bazookas.
You had what was the one you had? A Cobra? It was a folded dipole.
Yeah, the Cobra is basically it's a doublet, but it's shortened because it's linear loaded. About I think 3 times. It goes out, back, and then back out again.
Do you want to be on?
The only problem with it, if you try to set it up for port, I set it up at in Arizona there one time in Quartz Fest, and it's heavy. It's a heavy antenna. Right. But I also made one out of. I made one out of.
You better now.
Cat 5 also that was flat. It was kind of hard to solder, but I got it soldered. Because you had to solder every other end, you know.
Yeah, I got you.
It worked good. It was way lighter.
I'm not sure I'm a fan of the linear load, to be honest with you. I know people. I'm not a hater. I get everybody upset, but
well, it's not going to be as good as full size, but it saves space. There's some guys that made the ones that go down. Have you seen that one where it goes over, then it goes down, then back up, then over? It just keeps doing that, so you can physically make it shorter if you have a small backyard.
It's Mike's radio repair. I didn't think that those bleeder resistors cost very much. Hey, Mike, how's it going, brother?
Yeah, I wasn't thinking bleeder resistor. I was thinking one of those other inline antenna resistors.
I was about to say like a mega ohm resistor shouldn't cost, but a little.
Good to see you, Mike.
Good to see you, Mike.
Are you talking about the ones for the beverage antennas?
Yeah, that's exactly what I was talking about. There's a name for the antenna that I was talking about. I cannot remember the name of it right now.
Wasn't it Don that was pushing that thing? I think Don was pushing that in our chat one time.
He was, but somebody else was pushing them too with the terminated dipole, dipole, and they had a big resistor on there. They had one of those $200 resistors. But I mean, the thing is big. It's not like soup can big, but it's probably the size of like a pepper shaker or something like that.
Palomar's got a little self-bleeding dingus that you can just put in line.
There you go. All right. So what is the antenna gain and how is it measured? You want to take this, Chuck? You seem to be the gain guy around here.
What's that now? What is the gain and how is it measured? Yeah. Well, gain is usually put against the dipole because dipole is like the level part. What do you call it? It's where everything kind of starts. And by adding reflectors and directors, you basically close off the rear. If you look at the bottom of that, the bottom is closed off pretty much compared to the top. And the nice thing about that is, especially if you lived in like the middle of the United States, you know, you can turn it away from people. You'll still hear people, but you're going to hear the people that are in front of you better than you hear from behind. And I've had guys break in anyhow. I mean, just, I don't know why, but sometimes I had a guy, I was doing 6 meters one time and this guy just like blew right into my antenna. But
yeah, but it's really about energy,
backside,
concentrating energy and focusing it in a different direction.
Yeah. You want to concentrate it to well, it depends on how many. It all depends. I had some guy complaining about it. When I was doing that video the other day, I said I mistakenly said I can hit China, Japan with it the other direction. Actually, it was actually more Australia. He was semi-right, but he was generalizing the United States is all the same, and it's not. Yeah, it's where you live. It's where you live in the United States. Yeah, you want to direct the more elements you put on, the narrower. Sometimes being really narrow, now you have to be right on that person to really hear them sometimes if you get a lot of gain.
Yeah, these gain charts, I believe, are from a 4-element Yagi for 20 meters. And
probably a full size one.
So when we talk about gain, it's the addition of power, like we said, concentrated and moved into a certain direction, or a comparative number, like a relative comparative number to a different antenna. So you'll hear people say, "Oh, what's that?"
Can you read the gain on that? It's like probably around 8.
I cannot, dude. My eyes are so bad.
I can't see it.
But people will say, "Hey, well, this gain, this has 3 dB gain on an antenna, and that means it's 3 dB better than a dipole antenna." Now they're probably taking the gain measurement from the worst part of the dipole and comparing it to the best part of the antenna that they're selling. Never trust
13 decibels.
Is that what it says?
I think he's got the young eyes. And
probably more than
they're going fast. They're going so fast.
Wrong.
If you see dBi, it's a comparative number to an isotropic radiator, which is a theoretical antenna in free space.
Fictional number.
Yeah, you can't build
2.5 away.
Can't build
2.5 away. DBD.
But then also with directional antennas,
4 elements.
Like Chuck was mentioning, like you do a front to back ratio, which compares the forward facing gain off of antenna to the backwards facing gain. And the gain for the power out isn't as always as important as the front to back ratio, because as Chuck was mentioning, the front to back, the worse your antenna hears from the backside, the less signal to noise, the lower signal to noise ratio you have. I should say higher signal to noise ratio. The better, we'll say that, the better signal to noise ratio you have, because you're not picking up all that other extraneous noise. You're concentrating on the signal that you want to hear. So like here on the left-hand side is looking down on this Yagi antenna, and you can see facing north is where its energy is focused and the strongest. Facing south is where it's the weakest. On the right-hand side, you have horizontal polarization, I believe is what that's called. And you can see the lobe direction where your energy is being forced or focused coming off of that antenna. So they work really, really well. Like Chuck was saying, if you're trying to sharpshoot and get a signal to go a certain direction.
And they're way quieter. If you've never used a Yagi, if you ever had a chance to use somebody's Yagi, just especially if they have multiple antennas. I mean, sometimes I'll listen if the band's really bad, it's really noisy. My buddies in San Diego, I'll listen to them off my Yagi, which is not, it's for 20, 10, and 15. But their signal is like almost gone, but I can totally hear them because there's no noise that way, especially on that band. So it's by rejecting to the sides and to the back, it makes everything a lot quieter. Not always, but most of the time.
Chris is saying that centers in general have CMs common current issues,
and he's not wrong. He's not wrong, because you're really upsetting the whole balance.
Well, the thing is that I always operated under the impression that a all-center fed dipole was an unbalanced antenna. It's technically balanced, and that's a holy war debate that I don't want to get into. But when you have an antenna that has more on one side and less on the other side, you're more prone to common mode current than if they were equal on both sides. I always have common mode current problems on my end-fed half waves. Bad, and that's what got me into chokes and building chokes and measuring chokes and doing videos on building and measuring chokes, because I was having common mode current issues that were so bad that my computer would shut off, my monitors would shut off, my RF.
I remember the monitor problem. Yeah,
my ground fault isolator in the one bathroom would kick off. I mean, it was just it was a nightmare. I was getting ready to pack up all my equipment and throw it in the trash.
I actually tripped a GFI in my kitchen while I was playing around and transmitting on my 2-meter handheld HT.
2 meter activates a lot of stuff around the house.
Have you done that, Chuck?
Have
you tripped a GFI by being near it with a 2?
I don't know if it was.
Reader? Everybody in the chat, you need to experience this for yourself and then get back to us.
I could be hallucinating, but I've done it.
I know I've set my wife's dryer off before with, I think, 2 meter.
I was like, honey, look how cool this is.
Run some power,
Yeah, I had a TV that if I keyed up my 2 meter radio, the TV would turn off.
Nice.
I know when I do stuff out back, the spa turns on and off on 2 meters a lot of times.
Well, I have a fan so I have like one of those tower fans that oscillates back and forth. And when I transmit on 20 meters, the fan changes its power setting.
Nice.
Like it'll go from high to low or low to high.
That's when you know you're peak ham.
Right. That's when you know you're putting watts in
putting
the
it
air.
down. That's right.
John was asking about delta loops.
What's he got to say? What about delta loops? About
yeah, what about them, son?
What about them?
What you know about delta loops?
I know that the Green Mountain Maniac, Steve, over in where's he lives in? I forget where he lives. He lives on the East Coast, but he had two of them. One is a reflector and one is a driven, and he used to just like kill it into Europe all the time with that thing.
VTY says he trips his neighbor's GFI. That's awesome.
Oh, that's even better.
That's a lot of
depends on your neighbor, I guess.
So I'm not going to say you can't get common current with a delta loop. You probably do because you can get them with well-made dipoles. I guess you would argue that a delta loop is inherently balanced. I would put a choke on it. I put a choke on every antenna, and I guess that's the. Yeah. I don't know if that's the answer you're looking for, but
real quick, Prep Ham Paul just messaged me on the back end of Discord, and he showed me a picture of a coaxial lightning arrestor. And I want to bring to everybody's attention that is not a static bleed off device, because it's mostly concerned about disconnecting the entire antenna, not constantly shunting to ground. So a lightning arrestor and a static bleed off device are not equal.
No, they're probably two different things. But
you will actually lose signal with your static bleed off device, but it's not worth talking about. It's behind the decimal point.
Yeah, I would suggest if you can't ground via a lightning arrestor, and that should help you out. But even if you have all that stuff in place and you start monkeying around with your coaxial cable, before you hook it back up, I would still short it out. It's just a best practice.
That's right. KO4 PDI knows all about this. He says a Morgan does both, and he's absolutely right. I totally forgot because I don't own any of it. So yeah, he knows. Everybody listen to KO4 PDI and please subscribe to his channel because he does the #1 satellite passes on the daily of any ham tuber.
And he smoked more equipment than anybody I know. I'm just kidding.
And he's still on the air.
All right. How high should my antenna be? And this is a funny one because like I had a buddy that had an end-fed half wave mounted in his backyard, and he had it running across the top of his wooden fence. And the fence was shaped in a U, so he had it going in a big U pattern all the way around it. And that's where the antenna must have been 6 feet off the ground or something like that. And he sent me pics, and he's like, "What do you think, man?" And I was like, "Bro, I mean," I said, "Give it a try, but you know that's gonna be terrible." And he was killing it with FT8, so he had a good old time with it. And I guess that's all that matters if he was having fun with it.
Well, that's good for like HOH maybe also. If you don't have if you can't put something up in the air, right?
Yeah.
Something's better than nothing.
Yeah. And so a lot of people will mistakenly think that they have their 20-meter antenna, 10 feet off the ground, and that they're doing NVIS. NVIS is really something that works on the lower bands, like 40, 60, 80. It's not something that actually works real well with higher frequencies. The other thing is that in order to communicate NVIS back and forth with somebody, generally speaking, they need to have an NVIS configured antenna as well, because your incident angle goes nearly vertical. That's why it's called near vertical incident skywave, and it comes back down nearly vertical. If you take a look at this, these plots here, these far field plot, you can see that this antenna kicks most of its energy off at around a 30-degree angle. So anything that's coming straight down, it's going to have low gain when we're talking about gain, and really not work well for NVIS. Generally speaking, horizontally mounted antennas, you want them to be around a half of a wavelength off ground. Where it gets tricky is that if you have like a 15, 20, 30 meter Yagi or something like beam, adjustable beam on a tower, you really can't keep lowering it and raising it and stuff like that. I'm sure there's some out there where you can. And so you have to compromise a little bit, but the height above ground is definitely going to impact your radiation pattern. These are both diagrams of a 20-meter half wavelength off of ground. One is the horizontal far field plot like we looked at earlier. The other is a 3D radiation lobe that you can see there.
Who did that modeling? Did you do that?
I did.
Nice. Very nice.
Anyhow, higher placement generally improves radiation efficiency and signal reach, but if you go too high, your radiation patterns can get goofy as well.
You can be too high.
You sure can be too high. And then UHF and VHF considerations. With those types of antennas, I say get them as high as you can in the air, because line of sight is really the important thing that you're looking for at that point in time. And the impacts of ground are lessened. I'm not going to say they go away, but it's less of a deal with UHF and VHF antennas. Here we go, Ziggy. This is I'll put this one in here for you.
And can I use a CB antenna for ham radio? Hi, everybody. My name's Ziggy, and I use 10 through 12 on my 102-inch whip on the daily. It works great. But Ziggy, what about that mismatch? Do you have a manual tuner or an automatic tuner, like an outboard, like automatic tuner? You're good to go. You can also alter your fixed radiating element antenna, whatever you have, by simply increasing or decreasing, mostly increasing, to shorten the frequency of the length of the radials that are coming off of the antenna. So it's totally possible, and I think that a lot of people give the CB 102 whip zero credit because, you can simply attach to that at the tip and run out a longer wire extension, and now you have an indestructible half square.
Chuck, you did a video on using I can't remember what the antenna was. The A1, is that right?
The A99, Antron 99, which is actually their smaller antenna. They're guys talk about those all the time for 10, 11, and 12.
We should talk about the Antron 99 on an entire stream because there is so much to talk about.
Yeah,
there really is.
Hey, Hollywood.
I love that. Hey, Hollywood. I'll use resonant tuners. That is the best thing I've heard today.
Our friend Mike saying, is DX Commander the best choice for multiband verticals or something else?
Sorry.
I don't know, man. I would be hard pressed to say. I'd be hard pressed to say no on that because a lot of the other multiband verticals that I see are loaded with traps all over them, right? Traps and coils and gizmos and gadgets, and they really mess with the Q of your antenna. If I had the space and I wanted to put up a big old vertical antenna, I'd do a DX Commander. Do I think that there's issues with that?
Right.
Well, yeah, with that, yeah. But with the DX Commander, you definitely can get a bunch of them. But yeah, something like a Poseidon that we did works really well.
I still gotta elevate mine after John did the numbers on that. It was really good at like 6 feet.
Yeah, I was gonna say it was like 6 feet off the ground, right?
I think it'd be pretty close on a full size DX Commander.
I got to put an antenna up. I don't have one up because we've been having storms. I think I'm going to put the Poseidon back out there.
I hate to admit that I have two 11-meter antennas up right now.
Do you?
Two.
I have a Tornado. It's I think it's a little better than the Antron. It's an actual aluminum 11-meter. Well, it's 1110. So it'll do both. One of these days, I actually might set it up as a 10-meter vertical.
So what's cool? Hold on, let me stop you right there. What's cool, everybody, about doing 10 meters on an 11-meter antenna is that you actually end up with more mismatch, but you get a lower angle of radiation. So you actually get a bit of a DX monster on 10 meters on an 11-meter antenna.
Well, a lot of the LCB antennas. What was the what was the one that everybody liked? It was a ham radio antenna. The super penetrator. I forget who made that.
The super penetrator.
Yeah, and it was
Are you talking about a stinger?
Popular,
like a coil loaded stinger.
The high gain high tower.
It had a coil. It probably. I'm gonna look it up.
Chuck's all over it. So no antennas in up in the air right now, eh? Abe?
None right now. Look at this. Our buddy Dave over here. He's saying he's got the Commander Classic and the Poseidon in the backyard. Can't tell much of a difference.
That's right.
Really?
I tell you.
Okay, it was the high gain. Here we go. It looks. Oh no, so I don't think they sell them anymore. It was the high gain SPT 500 Super Penetrator HF vertical antennas. It used to say not for use for 11 meters, but it does 10 and 12.
10 through 12. That sounds like 6 through 160.
Yeah. So, well, it could be tuned.
Right.
That was like the go-to antenna for a lot of guys on that want to put a vertical up, and you mount that thing as high as you can get it. Very similar to that tornado that I had, except probably better built. But I guess you can't buy them anymore. When I first started ham, and you could still buy them and it flat out said not for CB use.
Well, a lot of people, like to hate on CBs and stuff like that. But I got to tell you, the CB bands are filled with hams. Like there's tons of hams on CB.
I met a ham on CB, and then he told me over CB his ham YouTube channel.
Check out my YouTube channel on ham radio, even though I'm operating CB.
Right. Yeah, we bumped into it. He's like, I'm radio man, da da da. And I was like, all right, dude, I'll give you a sub. And then I look and I'm like, this guy's doing content every day on 11 and 10 meters. I'm like,
that's funny.
Yeah, it's good.
Here we go. How does ground conductivity affect vertical antenna performance? And it's important, right? Poor ground conductivity leads to ground losses and reduce. I must have cut the bottom of that off with my vertical antenna and ground radial diagram that I put on there. But the thing is that when you have a quarter wave vertical antenna, it's looking for the other half of that antenna when you're transmitting, and that power a lot of it goes down and gets absorbed into the ground. So you're losing a lot of power and a lot of signal there. One of the things is that a vertical antenna, quarter wave vertical antenna, has got about 32, 33 ohms of radiation resistance, which is low. It's not the lowest antenna, but it's low. So you lose a lot of your power to heat, and then you lose a lot of power due to ground absorption. And if you have a coil loaded vertical, you're losing a lot of your power as heat in the coil. So ground radials are super duper important. Now, is that a problem if you're operating at the beach over some ground that's saturated with seawater? Probably not, because that would be conductive ground. But if you're not, put out some ground radials and you'll immediately see a big difference. What the ground radials do is they mitigate poor ground or soil conductivity. If you elevate your radial so it's not a ground mounted vertical, and I'm not sure what the height above ground where it's no longer ground mounted and becomes a elevated vertical, you actually have to use tuned radials. But if you're on the ground, just as much copper that you can get on the ground, it helps your conductivity. I like to use a quarter wavelength radials for the lowest frequency that I'm operating on. And a lot of people are like, well, if my vertical's mounted up against my fence, is it okay to put radials on one side? Sure, but you're going to lose power on the side that you don't have them, and you're going to be weaker chasing signals in that direction. If that's all you got, put it down. But if you can, try to get ground radials all the way. It helps lower your takeoff angle, and you'll get better DX with that.
And it'll prevent a lot of your RF being thrown into the ground.
Yeah. So the RF will come off your antenna, hit that radial plane, and then bounce up.
Well, yeah, more or less. It wants to be away from it.
Yeah, well, that's what it does. It comes down, hits it, and bounces away from your antenna. But also, incoming signals will hit that ground plane and then bounce up into your antenna as well. So it helps with RX and TX when you're chasing the DX.
What's he saying?
VTY saying that he's got a coil loaded CB mobile rated at 10,000 watts. I believe it.
I mean, they all said, what was that we saw so long ago? It was called the Big Mama. What was it? Do you remember?
That big giant porky coil that was looked like an oatmeal can from the 80s.
But it was the Big Mama though, right?
I can't remember.
And the face of the antenna. Anyway,
we sent so many pictures of goofy antennas back and forth. I can't remember them all. So what are harmonics and how do antennas respond to them? And so harmonics are multiples of a fundamental frequency. So if you're transmitting on 7 megahertz, for example, a harmonic of that would be, the second harmonic would be 14 megahertz. Third harmonic would be 21 megahertz. Fourth harmonic would be 28 megahertz.
And every harmonic you traverse a little bit less power.
Yeah. So yeah, the harmonics are generally not as strong as the fundamental frequency. But what I did on here is I have some sine waves down at the bottom. In the blue one, let's say that's a 7 megahertz sine wave. It's one cycle, right? So you start at 0 voltage, go up, go down, and then back up at 0. The green line is 2 cycles, right? So that would be why you can use a 40-meter antenna, like an end-fed half wave, on 20 meters. You can also use it on 15. So if you take a look at the red, you have 3 full cycles in there. So those frequencies are harmonically related, and it's no coincidence that in amateur radio, the bands that we were originally granted permission to use, sounds weird saying it that way, are harmonically related. When you start throwing in some of the other bands like 12 and 17, and that kind of messes that up. But originally they were harmonically related bands that we were using. Now, I wonder if Ziggy's OBS died, or if he's blowing his nose and doesn't want somebody getting a picture of him doing it.
Interesting. Well, probably not, but I am.
Here's one. A lot of people say, what is the near field and how's it different from the far field? So the near field region is generally around a quarter wave of the frequency that you're operating on to a wave. It can vary a little bit depending upon the antenna and the frequency that you're operating on. When you transmit your antenna, you have radiation that's coming off of that, and they refer to it in 2 different ways. They'll call it constructive and destructive radiation. So some radiation coming off the antenna will work with other radiation to point a signal in a certain direction. Other destructive radiation will cause interference and cause null spots or cause problems for you. It's one of the reasons why directional antennas work the way that they do. But you have a lot of chaos in that near field. And this is one of the reasons why I say I don't like carbon fiber antenna masts, because that is a conductive piece of material that can cause reactance to the energy, your electric and your magnetic radiation coming off your antenna in that near field. Just beyond the near field is something that's called a transition zone. Some folks will call it the Fresnel. I like to say Fresno because I'm a redneck, but the Fresnel region. And that's where your radiation starts to sort itself out and determine how it's going to radiate in which directions and at which strength from your antenna. And that is what is visible in the far field of your radiating zone. People will take different measurements with things like field strength meters and nano-VNAs and tiny SAs, but you really want to be in the far field if you really want to get an accurate representation of what your antenna is doing, because of that chaos that's taking place in the near field. One of the analogies that I've heard to kind of describe this is like, imagine you're in a boat and you're kind of speeding across the pond or the lake or whatever, and the water splashing off of the body of the boat is chaotic. It's splashing, it's going all over the place. Think of that as your near field. Once you start to get a few feet out from the boat, you have waves, like they call it your wake. And that wake is very predictable, right? You can watch a boat go across and you can see the wake coming off of it, and you can even gauge where it's going to be. Even further away from that, you start to see the ripples that go across the lake, and that would be your far field. How often do you guys get asked about the near field versus the far field?
Never.
45 carries a Fresnel lens in his wallet. I imagine that's so you can read the menu at Olive Garden. People pull those out all the time. And that's my last slide. I thought I had more, but that's the last one.
That's it?
That's it.
You're slipping up, man.
I thought I had more, but that was it. Oh, thank you.
No, that was perfect.
Timed that one pretty good.
Yeah.
So, Chuck, what do we got tomorrow? We got the special edition of Coffee and Ham Radios coming up.
Coffee and Ham Radio. I think we're doing Field Day. Talking about Field Day, right? And guys, don't miss that for anything, please.
That's right. That's right, Chris. Lubricate said you're right on time. He probably just joined. I didn't see him in the comments earlier.
I didn't either.
What's up, LC? And then, hey there, Starman.
Yeah, I think
what do you got going on, Ziggy?
What's that, buddy?
So what do you got going on?
What do I have going on? So I took down the loop. I'm rebuilding my very first infed half wave on a not a type, a mix 52. So this isn't a minty, right? It's green on all sides. This is a mix 52. And the cool thing about a mix 52 on an infed is that it's most efficient on 80 and 40 because, as y'all know, 80 and 40 is the way to go with a long wire. If I wanted to be on a higher band, I would make a higher band impedance match transformer.
Yeah, when I first started talking to you a while back, you were always on 80. That was your thing. That was your jam.
I'm at 75.
Right,
75 meters. Yeah. And then I also have to, you know what? I never did ship you one of those 75 meter mods for the infed halfway, but I know that you're space constricted, so that's probably why I never sent you.
Yeah, I definitely don't play around with the low bands that much because I'm space constricted. But those green toroids like that are getting very popular. I'm starting to see on lots of commercial antennas these days.
Yeah, really good for the lower, like 80, 40, and 160. Nothing above that. And in fact, I don't know if you can make it out. Do you see the lines?
For heating that thing up?
Those are previous wraps of being on the wrong band, fellas.
What's up, Brent? How you doing, bud?
You could just barely make them out. But yeah, the heat actually changed the paint.
Might have to take a look at it.
Yeah.
Anyway. So Chuck, were you in the middle of saying something? I can't remember.
Oh man, John just noticed. Yep, this is a permanent addition. My buddy Grouch has a permanent spot on my microphone now.
Well, look at that.
Yeah. He puts up with me, so I can stick him.
I think I'm gonna go grab some Miller Lights.
That's right. Chuck, good to see you, buddy.
Well, hey, thanks for everybody for watching tonight. Greatly appreciated. If you have any questions or comments, go ahead and post them in the comments.
Don't forget tomorrow night.
Yeah, don't forget tomorrow night.
What time is it? It's 7.
And don't forget, everybody, hold on before you kill it.
Take your time, son.
I'm typing. If anybody wants to send me any question, boom, send it right there. ZiggyBuilds@gmail.com.
All right, I'm hitting it. Thanks, everybody. Much appreciated.
See you guys.
All right, hit it, man.
Check you later.